Hi everyone, welcome to this video series on Essential Statistics, a primer module for data science and machine learning. As usual, we'll be talking about the foundational concept along with the Python code demo. In this particular video, I'll be focusing on symmetry of data and we'll look at some of the measures to calculate the symmetry, and we'll also discuss why symmetry is important or something which is not really important also for some of the machine learning models. So data symmetry and what is data symmetry in the context of data analytics, it actually refers to a balanced and proportional distribution of information within a data set. It involves the evenness or sort of symmetry of the data structure, where the patterns and characteristics or the trends are distributed in such a way that it reflects a sense of balance or proportionality in a way that half of the data on the left hand side and the remaining half on the right hand side. So understanding symmetry is very crucial in the data analysis, as it influences and it helps us choose the right machine learning model or statistical models, and which thereby allows us to talk about the reliability of the model and so on and so forth. So what is data symmetry? Refers to the situation where the data values are distributed in a balanced way or mirror-like pattern. So if you were to draw a line through the center of the distribution, so then the half of it will look like one side is the reflection of the other side. Typically, normally distributed data will be such, if you draw a line, so this side and that side would be like a reflection of each other in terms of probability and probability density. So why we measure symmetry in data? Because it allows us with valuable insight underlying distribution of data to understand the spread of data around the central measure, and thereby the it also helps us with the choice of a statistical model and build a highly accurate model with the right methods. So how do we check for asymmetry or symmetry? One simple technique is to use visual plots like box plot or a density plot. Like in the data distribution, we have a normal distribution and uniform distribution and so on and so forth. And there are other measures also to determine the skewness. The one that we will talk about in this video is going to be the measures like kurtosis and skewness. So let's look at these two measures, how that really helps. So the box plot or distribution plot come under the visual methods. You can use all of those methods. We have talked about the box plot and density plot in the previous video, so I'm not going to spend much time here. So what is kurtosis? Kurtosis is another way to look at the distribution and the shape of the data. Two important things here. One is the tail of the distribution and the peak of the distribution, and how that helps us, talk about the quality of data. Having heavy tails or light tail or very pointed peak or a flat peak, that helps us in terms of understanding the extreme values in the data or outlier data. So for example, this one is the normally distributed data, and in this case is neither too heavy nor too light, and the distribution has tails and peak pretty similar to normal distribution. They can have some outliers, but not really bad. So this kind of the plot is called mesokurtic. Now we look at the excess kurtosis. Let's say we have a data column with the closing values of the stock for every day for a year. and then we plot it. On the x-axis would be the closing values, and the y-axis would be the frequency or the count. So the bell curve would be either slender or a steep bell curve, high number of occurrences for just few closing price, and wider curve or less steep closing values are now varying very widely. And those are the cases that we look for in such curves. So they are indicative of outliers. So interpretation is excess kurtosis is observed when the bell curve has a fatter tails, like a long tail, indicating a higher probability of extreme values or outliers. So, for example, leptokurtic distribution is called positive kurtosis. So here, if you look at it, you have the data and there is a long curve on the right hand side. So that means the closing values are higher than the normal. So in this case, the kurtosis will be substantially greater than zero. Such distributions have heavier tails and they're leading to more pronounced peak here because most of the values are on this side. So extreme values are likely to occur in such cases. Now, the other one is the negative, which is like substantially low value. And if you notice here on this side, it will be a substantially lower kurtosis and it's called negative kurtosis. Again, this is extreme values are less likely to occur and the data has less variability in the distribution. So what are the applications of kurtosis is it is used to get the insights into the shape of data and the distribution of data, identify potential outliers or extreme values. High kurtosis does not necessarily mean the bad data. It simply signifies some presence of extreme values. Interpretation of kurtosis can really vary depending on the context and the problem statement. Let's look at another measure, skewness. Skewness is a statistical measure that quantifies the symmetry and asymmetry in a different way. So now we are looking at a positive skew and a negative skew. Let's take a look at some of these examples. The positive skew is also called right skew, and the tail is on the right side of the distribution. And in this case, the tail on the right side of the distribution is longer and fatter than the left hand side. Just the opposite here on the negative skew. The tail on the left hand side is longer and fatter than the right hand side. Some examples of right skew income distribution. So most people actually earn moderate income, but some individuals may have very high income. Home prices in a neighborhood typically have a common range or something, but there could be some luxury homes with much higher prices. So these are distributions which will look like this in both cases. Aging population also can be an example where distribution of ages in a retirement community can be positively skewed. So in this community, most of the residents would be, let's say, around 60 to 70, but some residents could be close to 90 or even 100 or 110 plus. So these are right skewed or positively skewed data. Some examples here in terms of plots. So when you plot such data like age distribution, so most of the data is here, but some data can exist on the right hand side. Income distribution, again, most of the data is here. Some data can be on the higher side. Home prices, again, most of the houses are, moderate price, but some houses can be extremely luxury and they can be really expensive. So just the opposite. So where the opposite can happen, some of the examples, if the class entire class performs exceptionally well, and some of them are a few students who perform poorly. So that's the example of opposite. Company earnings in certain industries, the distribution of company earnings may be less skewed. Most companies can do well, like a moderate profit, but few companies can be experiencing a low or a loss, less skewed. So likewise, there could be practical examples again with the exam score, for example, on the left hand side. Few students did not do well. Most of the students actually did well. And company earnings also, most of the companies are earning pretty okay. Some companies are not so okay. So these are examples of left skewed data. How do we calculate the skew? The positive skew typically have the values like this, and there is some guideline which I'm going to show you in the next example. And here is his negative. So this is also negative here, negative, negative data. And the guideline is if your skew value, which can be computed by SciPy. So if you fall under this region, zero point 0.5 plus and minus, that's fairly okay. Anything above would be like positively skewed, and anything on the this side would be negatively skewed. So as we discussed, this is all context dependent. Do we fear skewed data too much from the machine learning side? Skewed data can pose some challenges in machine learning, but it's important to really understand the context. You cannot apply the blanket rule like this here. So understanding the implications and the appropriate strategies is important. So some considerations. Now, some columns may exhibit skewed pattern in the data in that particular data series. But when you combine all the features together, then things might balance out. So that means the effect of skewness might be reduced when you look at multiple columns. So machine learning models, many machine learning models can perform pretty well with even skewed data. And if you you can apply some feature engineering to transform the skewed data using some of the techniques here, like log transformation, box transformation, and so on and so forth. But important thing is to first apply the model and evaluate and see how the model is recognizing the data and how the model is actually performing. Domain knowledge plays a very big role in understanding or the impact of skew. Next, let's take a look at the Python code to understand how this actually looks like in terms of coding. Let's look at a simple example here with some dummy data. So here are the stock prices that I showed you in the slides. So making up for the data which will return high kurtosis. And if you plot, this will look like this. That means there are some extreme values in the data series. Similarly, we can also simulate the data series in such a way that it will return the negative skew. Okay, for example, here in this particular case, there are some lower values on the left hand side, but not too much. Let's apply the kurtosis on a California housing data set. The kurtosis can be computed using SciPy. So load the data, and then we apply the kurtosis on each of the column. For every column, we're going to apply the kurtosis. So if you notice here, this is negative. Okay, so that means there are some lower values. Similarly here also, and here also. And then this is the case with the extremely on the right hand side, you will find a longer tail, and that means it has possible outliers. So here, for example, this could be a perfect case here. In this case, is not able to compute. Maybe there are some null values here, so that's why the kurtosis is also coming out. And in this case also, there are some high values possibly. Population is coming out substantially greater than 0. And the same way here, the household also has significantly high kurtosis. These can be topic of further inspection and really finding out whether they're really big enough or not. This is kind of okay. This is pretty flat also at the top, so it doesn't look like it has high kurtosis. So that was the quick intro to symmetry of data using understanding symmetry using skewness and kurtosis. Thank you all. We'll see you in the next video.